Okay, so here's the problem. A small ball of mass m, small m, is connected by an inextensible massless string of length small l to another ball of mass capital M equals 4m. They are released with zero tension in the string from a height h as shown. The time when the string becomes taut for the first time after the mass capital M collides with the ground is, and we're going to begin 4 options, and we have to assume that all the collisions are elastic. So this is the diagram. The larger ball is lower than the smaller ball, and they are released. The tension in the string initially is 0. The ball, the bigger ball drops from a height small h. So while they are both descending, both balls will be traveling with zero relative speed because they're released from the with zero speed, and they're both under the acceleration due to gravity. So the relative velocity between them is 0, and so the string will remain tensionless. When the bigger ball reaches the ground, having descended a height of h, the speed of both balls will be u is root 2gh, and that will be in the downward direction. Now the bigger ball collides elastically, and so it will rebound with a velocity, same velocity, upward. So u equal to root of 2gh upward. At that instant, one ball is traveling down with root of 2gh, the other is traveling up with root of 2gh, and so the relative speed of the two balls will be 2 times root 2gh. Now the balls are subject to the same acceleration, and so the relative speed between them will be constant. And so for them to collide, they have to travel the distance of the string, which is L, and so the time taken for them to collide now will be T1 is length divided by speed, and so you get L divided by 2 root 2gh. Now the collision between the balls is also elastic, and therefore the velocity of separation equals to the velocity of approach. And so the relative speed between the balls after collision will be vrel, and that will be equal to urel, the velocity of relative speed before collision. So that's also 2 times root 2gh. Now the string will become taut when the distance between the balls has become L again. They've collided, distance became 0, they're moving apart now, and the distance needs to become L. So this will take a time t2, again distance divided by relative speed, you get L divided by 2 root 2gh, and so the total time taken is just the sum of t1 plus t2, which is L divided by root 2gh. And please note, just as an aside, because we have been given that the collisions are elastic, the ratio M, capital M to small m, does not affect the outcome.